They buy the chip. And how close they are to the market, then the picture always changes. So you would always order these groups differently. So this really reflects this complexity, the diversity of these situations. And where it becomes really interesting for us as interested in infectious diseases, that these smallholders tend to be less well trained, less well monitored, and here the institution role also comes into play. The surveillance and reporting system can also be somewhat problematic in some of those areas. And so Dingra and colleagues, who have been compiling all documented events of reassortment of highly pathogenic avian influenza, have identified the fact that a lot of these events are in areas where the production system is currently transitioning from backyard poultry to intensive poultry production. So this is indeed something that should really draw our attention. Next slide. Okay. So these human aspects matter, I think, because there is diversity, and it's interesting to document and at least to think of this diversity. And it has been in some cases that could matter poorly documented. The institutional context matter. So what are the priorities? How well does surveillance work? What are the areas that are prioritized for training or topics? And one interesting thing also is that land use does not exist in isolation. And this is also particularly relevant for livestock production in the context of certainly in semi-intensive and intensive system in particular. There is a lot of discussion in the field of sustainability on the issue of, why do you feed these animals with? Where does the food that you feed these animals with comes from? So these come into broader system that are interesting to look at. So how can we go about this? So there's three big families of tools that have been used in this context, and certainly you are familiar with some of them, I am sure. So the mechanistic models, like the R0 type of thing, the statistical models, so species distribution model, niche distribution model, statistical model, regression models, and also other approaches such as simulation model or multi-criteria decision analysis. So these are tools that you may be familiar with already, and they've also been used in the context of disease as a human environment interaction. So mechanistic models have been used in this context as well. And so this is another study by C.I.Z. and colleagues that looks into malaria in frontier regions in the Amazon, in the Brazilian Amazon. And basically they include in this model the idea that when you modify the landscape, when you disturb the landscape, the forest landscape, you create all these habitats for Anopheles mosquitoes. This has been documented quite extensively, but then these areas continue to live their life as a frontier, as an agricultural frontier. And indeed, there can be more or less institutional investment into controlling this problem. So is there an investment in controlling the problem? How is the economic power of people changing in a way that can affect their capacity to deal with this problem, and whether people are diagnosed and treated really effectively. And so this demonstrates the fact that you cannot predict the outcome in these frontier regions only based on what happens for the vector. So the drawback from our point of view of these mechanistic models, they are very powerful, but usually they're not spatially explicit, not necessarily a problem, but certainly something to keep in mind. And of course, in this context, as well as in the context, the purely ecological context, of course, there's always a challenge in assessing the parameter values. One of the issues also is that the landscape factors are not included very explicitly. So you need to have a very good knowledge of understanding of the systems, and especially if you're in a context when you can have, forces working in different directions, as is the case here. So the empirical statistical models, so they broadly work based on a set of records. So you will have registered vectors, pathogen hosts, any number of indicators from the system you're looking at in a number of places, and you're going to associate that quantitatively to basically any number of environmental, socioeconomic, human-related, human ecology data that you want. So this is really the attraction of these models, is that you can really explore a lot of possibilities, really explore a lot of hypotheses when it comes to these relationship with the environment, with the human environment. And it's particularly attractive because these tools have become really accessible, and there's a lot of data also that can be summoned here. But of course, these models also have their own drawback, and one that's we should be particularly cautious about is that the fact that, as you know, from doing statistics, unless you make really formal hypothesis, there are no mechanisms expressed in these models. They're purely associative, and the risk of confounding can be quite strong. One of the things that we need to keep in mind when we work with these models also is that the data we use are always keyholes. So what do I mean with that? What I mean is that whatever data you have is only ever the tip of some iceberg that you're trying to look at, and most of it you don't see. And this is really important in the context of vector-borne disease or zoonotic disease, whether you look at human case or animal case or vectors or infected vectors. This is every time something quite different, and it's not giving you the same perspective at what you're trying to get a glimpse of through the keyhole. Also, of course, we can use any number of variable that takes our fancy there. So whatever we come across, we may want to try. But a lot of these are proxies, so indirect representation of conditions that are good or resources that the vector uses. So simulation model, I'm taking a look at the time. I need to move forward. So simulation model, they have a great flexibility, but the calibration can be challenging. So it's a similar problem than with the mechanistic model. And this is probably the main challenge, but you can formulate in any number, in any way you wish. And so they're really interesting as a sort of virtual laboratory for exploring setup of conditions. So I will skip the example to move forward and keep to the time. So one other way to look at these different possibilities is to see how hungry they are for data or not, or how well they will answer very specific research questions. So in this case, clearly, the statistical models tend to be really, really data hungry. So you need to have enough data to adjust them. And you need to ask yourself serious questions about what these associations you observe represent. For mechanistic model, they tend to be much, much less data hungry. So you still need to adjust for these parameters and identify values for them. But other than that, they are very powerful because the processes are fully explicited. But they tend to portray the environment in a somewhat indirect way. So what's in it for us? And again, as I said, for us, I don't mean just us people arriving from the land's perspective, but for all of us here today. And I think that something that's really, well, that I hope I have convinced you of, is that taking this perspective can really improve our understanding and the way we conceptualize the role of the environment. So whether that would be the human environment or the biophysical environment. I think it's really interesting to work in structuring and formalizing our understanding of land use change. So there's a lot of dynamic processes here. So we mentioned the intensification of livestock production system. This is one area, but there are other areas. And the fact that collectively as a species, we should ambition to think into more sustainable ways of producing our food. There will be a lot of dynamism, certainly in the coming years as well. I think it's really interesting to look beyond the simple land cover, land use description to consider management and land tenure also. And clearly, this is something I haven't mentioned before. What the land system perspective tries to do is to also understand the fact that when people make decisions about lands or about regulations, it's always a trade-off. So you always try to gain something, and sometimes you have to let go of something else. So it's always a compromise. I think this is true in our context that we work in as well. And so it can be an interesting addition to our thinking and looking for a solution. So the complexity of the landscape is something that's not decreasing. One very striking example of this is the urban-rural continuum, which in different areas of the world for different health-related issues has really come to light as where we need to focus our efforts of understanding. So the reason why these areas are particularly interesting is because they will mix urban character, such as denser population, with rural character, more vegetation, possibly presence of livestock animals. So an interesting environment to look at. And these interfaces are always where things are going to happen. We know this, and we've unfortunately had a very striking example again in 2 years ago. But this is something that's really worthy of our attention, and therefore understanding what shapes these interfaces is of interest to us. COVID has had really long-range effects potentially, and I'm sure we are not finished unpacking this stuff on land systems, also from our perspective. And so I'm sure that this is giving us more food for thought, if anything. And on that, I will conclude, and I will happily take your questions, I believe, later in the session. Thank you very much.